and joining us on another Spiceworks partner webinar, Don't Be Duped by Deduplication, brought to you by ArcServe. Before we get started, I do want to remind everyone this webinar is being recorded. If you have to step away for any reason, you will get an email with a link to the video in about a week. Also, there's a Q&A box on your screen to the left. I encourage you to submit your questions at any time during the presentation. We'll get to those questions at the end via a verbal Q&A, but if your question isn't addressed live, someone from ArcServe will be able to follow up with you. Now I'd like to introduce our presenters, Charlie Smith, Senior Principal Consultant for ArcServe, and fellow Spicehead Lisa Lyons. So Charlie, whenever you're ready, take it away.
Thank you very much. Good afternoon, everybody, and welcome to today's webinar. My name is Charlie Smith. I work in the UK pre-sale team for the ArcServe business. And today I'm going to talk to you about data deduplication, obviously the key topic. What I'll do is I'll run through the agenda and then we'll get started and underway. So the agenda is as follows. We're going to talk about what is the purpose and the need for dedupe. First of all, I know it sounds a bit of a basic question, but it's good to understand what's the implications of not having dedupe. I'm then going to talk about some unique technology, how we do global source side dedupe and how that works. And I suppose that's really the mechanics of what makes the data deduplication technology in ArcServe very unique in the marketplace today. I'm also going to drill in a little bit deeper about how we safeguard the data information, because a lot of customers that I speak to have concerns about, well, what happens if the data gets corrupt, you know, and it's all deduplicated, I won't be able to recover anything back. So I kind of explain a bit about how we do MD5 checksums to safeguard the hash information. So I'll spend a bit of time talking about that. I'm also going to talk about the different types of dedupe available, inline versus post level dedupe, and what's the implications for both, and what's the benefits and the drawbacks, as it were. We're going to talk about how we measure dedupe, because that in itself is a very interesting conversation. There's a lot of vendors out there that will give you kind of headline ratios. We get 30-to-1 data reduction. And really the truth of it all is that there are different ways and terminologies that you can measure the compression rates around dedupe. But I think the most important thing is understanding how much data you've protected at the front end versus how much is stored and retained on disk after it's gone through the process. And really that's how we measure dedupe. We're also going to talk about our ArcServe Unified Data Protection solution to give you some sort of context about how we use dedupe in our technology, and explain how the dedupe works in a bit more detail. And last but not least, I'm going to hand across to Lisa. Lisa is a fellow Spiceworks community contributor. She's written a great article about her experiences of implementing ArcServe, and she's going to go through a few slides and explain in quite a lot of detail about how she found ArcServe, the whole selection process before she kicked off a project, and other things as well. So I'm not going to steal Lisa's thunder. She's a great presenter, and she's going to talk through her experiences going through ArcServe. So, and then after that, we're going to have a Q&A. So there'll be plenty of time if you want to raise a question, and hopefully we can try and answer as many questions as possible as well. Obviously, there's a lot of attendees on the webinar today, so we'll do our best to try and answer the most high priority pressing questions, if that makes sense. So without any further ado, I'm going to move on to the next slide. Okay, so why do we need dedupe for backup? It's an interesting question, because even going back 3 or 4 years ago, before real data deduplication really came prevalent on the market, most customers only compress the data, either using tape hardware compression or software compression. And even though compression does have some benefits on its own, the reality is that customers were having to retain lots and lots of storage. And for that reason alone, I think it was fair to say that tape backup was the dominant media in the market. And the main reason for that is that tape media was significantly cheaper than disk. And we could hold and retain backups for long periods of time as well. And also it was a portable media that we could ship off site quite easily for disaster recovery protection. But what we've found over the last 5 or 6 years especially is that disk storage has become more prevalent in the market, and disk is a more reliable medium than tape in many ways, because you're not having to change media, you're not having to format tapes. Disk is just an online resource that's available to write to at any point in time, 24/7. However, when disk kind of came onto the market, the challenge was then is that how do you retain all this information that we're backing up, and especially now with virtualization and the astronomical growth that we see in storage that customers now retain and hold about their customers, the analytics and all the other compliance reasons. The amount of data that customers now retain is massive, and that presented a real challenge to the industry about how do we store all this data when the data just continues to grow at an astronomical rate. We want to use disk because it's come down in price and it's more reliable and it's cost effective, and really that was really the whole driving force behind data deduplication. And obviously ArcServe wasn't the first vendor to come to market with a data deduplication solution. We probably were one of the first mainstream backup vendors to introduce data deduplication in our traditional ArcServe backup technology. But I think it's fair to say that companies like Data Domain and hardware dedupe appliances really came into the market about 3 or 4 years ago, and really stamped their authority on the market. They were offering dedupe ratios way beyond any software-based solution on the market at that time. But what's happened more recently is that the software industry is really catching up now, to the point where we would probably argue that our dedupe is probably superior in many ways to a lot of the hardware solutions on the market. But anyway, going back to the key point here, this is an example of a customer retaining 4 weeks worth of backups. They've got 20 terabytes of production data, and then when you calculate that they have 2% growth on their data and a 3% daily change rate, you will notice that the first backup they would run would be a 20 terabyte full image. But then after week 2, if they have to do another weekly backup, full backup, they're going to back up the 20 terabytes that was already backed up, plus another 20 terabytes for the week 2 backup, plus the data growth of an additional terabyte, so we're up to 41. And then that equation just keeps on multiplying out to week 3 and week 4. And at the end of the month, what you've kind of found is that you've retained a lot of information without using data deduplication. So really, data dedupe is about addressing that, significantly reducing the amount of data. And what I'm going to talk about next is how we do the data deduplication to really fix that problem of cutting down the amount of data that you retain. So in ArcServe, we use a kind of patented technology called global source-side data deduplication. And what's quite unique about us is that the fact that we use source or client-side dedupe working in combination with inline target-based global dedupe at the same time. And I'll explain a little bit in a few slides' time the difference between inline and target-based and post-level dedupe as well, because that all becomes a little bit confusing as well. But essentially, when we take a snapshot on a server, the first thing we do is when we set up our storage pools for our backup on our recovery point server, which is our backup target, we set the block size, and the block size has a big bearing on the size of the amount of data that we will reduce. And essentially, the smaller the block size that we create, and the smallest block size you can create in ArcServe is 4K blocks, the dedupe ratios become very, very high, but it will use more resource on the server. And then as you increase the block size, it becomes less resource intensive, but the dedupe ratios are not as good. And when I say not as good, we're only talking marginal percentages here. Overall, it's still very, very good. And we have customers using things like 16 and 32K blocks as well to generate the hash keys for each data block. So that information is generated on the client or the proxy if we're doing agentless backup of virtual machines. And then the client sends the hash keys to the to the hash role, which is basically on the recovery point server. And the recovery point server receives this metadata, and then it starts to do a quick calculation. So if it calculates if the hash key already exists, i.e. the block is already known, because we've backed up the same block or a similar block from another node or the same node, and if it already exists, we basically just index that data block, because we don't need to copy the data, we just need to reference that it's already there, and then this block is going to point to the new recovery point, but we're not having to actually move any data because it's already there. And if the hash key does not exist, i.e. the blocks don't exist in our data store, we will send and transmit the unique blocks to the data store. So essentially what that's saying now is that we calculate what's the blocks are, we send that information across to the recovery point server. The recovery point server quickly calculates what's unique and what's not. If it's unique data, we will back up these new blocks. If it's not unique data, we will just update the hash pointers to the new recovery point and reference it to the existing block that's in our data store. And then basically the last thing we do is we add information to point to the new blocks and update the pointers. And essentially it sounds a bit complicated, but in reality what it means is all this is happening in milliseconds. And there's no resource, because a lot of traditional solutions that use source size dedupe put a big overhead on the client. They have to scan all the files and they do lots of work, and a lot of customers' perception of client-side dedupe is it puts a big strain on the client or the production system. But the way we do it, it's all metadata. So we just generate the blocks and the hash information, send it across to the RPS. That calculates what's unique and what's not, and then just transmits the unique blocks from the client. And the end result is that the backups run very, very quickly because we're only transmitting the unique data. Logically, we're moving the whole recovery point, but physically, we're actually only moving the unique blocks. And at the back end, we're doing global dedupe on all the data. So if we're backing up multiple systems with the same blocks and the same operating system and the same file data, we will only back up the blocks once and then reference them to all the other systems. And anyway, later on, Lisa's going to talk about, in real terms, what this actually equates to in terms of data reduction and compression, which is very, very high. So that's kind of how we do the dedupe at a mechanics level. I'm going to talk a little bit more about what we call the MD5 message digest algorithm, which sounds a bit cryptic in itself. But the reality is that, there are proven dedupe methodologies on the marketplace, and companies like Data Domain and others have got clever technology which is commonly available, and we've basically taken the same methodology to make sure that the dedupe data that we back up and all the information that's pointing to all these unique blocks and the reference points and the hashes are basically safeguarded and checked, because the last thing we want is a situation where customers can't recover the data and we get the blocks mixed up with the dedupe pointers and everything else. So the MD5 algorithm ensures that we generate a unique 32-digit hexadecimal number for any reference hash label. So in this example, the name Bob Spursum equates to that long number at the bottom, and that's unique. And if I typed in my name, it would come up with another unique MD5 reference number to match my name. So every value that we calculate, it gets MD5 checksummed to ensure that the data is valid and it can't be misconstrued to be anything else other than what it is. So it's a very, very secure algorithm that we use. Now, coming on to some of the variables around setting up data deduplication, I've mentioned already that you can set up different block sizes, and we allow you to create different size of blocks when you're creating your backup destination on the data store. And our default value is 4K, because 4K represents the most optimized data deduplication rates. So when we're using 4K blocks, and we'll talk about in a minute the best medium to store your hash database on to give you best performance on the server as well. But 4K blocks really do allow you to significantly reduce the data size. But there are trade-offs, and I'll give you an example. If you want to do disk-to-disk tape migration, sometimes it's better to have a larger block size, because when you do the disk-to-tape copy, it moves larger chunks of data, which will give you much faster performance when migrating to tape. If you're using a disk-to-disk only solution, there's a stronger argument to say have 4 or 8K blocks, because you'll get much more optimized dedupe ratios. And every time we increase the block size, you'll get the dedupe becomes significantly less, how can I put it? It becomes less compressible. So we will use slightly more storage as the block size increases. In terms of performance trade-offs, number of hash values to store, sort, compare, there's 2 ways you can really manage the dedupe database. One is you can put it into memory, random access memory on the server, and then we can just access it real time from the RAM on the system. But what we tend to recommend is putting a layer of SSD storage into a server that's acting as your recovery point server. And SSD storage gives you very fast read access to the information, and it gives you the best performance overall. So if you are using, for example, SSD storage, you can actually afford to drop the block size down to 4 or 8K, because you're going to get the performance on the SSD that you need to be able to read that data very quickly. If you don't have SSD storage, it's more advisable to increase the block size, so you're not going to hit the server as hard in terms of CPU and memory utilization on that box. In terms of inline versus post-processing, it's a good question, because there are a lot of solutions on the market today that use data deduplication. However, sometimes customers are not aware that there are different ways to deduplicate. Inline means that it does it real time, it does it on the fly. So as you're writing streams of data to your backup destination, which supports data deduplication, if it does it inline, it means it doesn't have to store the data on disk first before it sorts it out. It just reads it in, and it calculates what's unique, and it works out the hash pointers, and it does all this real time as the data is entering the server. If it's post-processing dedupe, it means you have to have a fairly large landing area on the appliance or the server to be able to hold the data in its entirety. And then once the backup completes, it will then sort out the data and crunch it down and remove the duplicate blocks. But the point is it's not as efficient in the sense that it's going to take slightly longer, because with post-dedupe, you've got to be able to land the data first and then sort it out afterwards, whereas inline kind of does it on the fly. The other thing is that with post-dedupe, you need a lot more disk storage. And there are a number of appliances, and both in terms of backup and data protection appliances and pure hardware dedupe appliances that customers use for backup as well, that use post-dedupe. And what you find with these devices is that the amount of disk storage they need sometimes exceeds the amount of data they can hold, if that makes sense. So you could have a situation where the customer says, I want to protect 20 terabytes of data, and he needs about 35 terabytes of storage in his appliance to be able to hold 20 terabytes of backup data. And the main reason for that is a big chunk of that storage has to be allocated as a landing area to hold the full image and plus is daily incremental before it can crunch it down. So you tend to find that inline devices need less storage overall because they're doing it on the fly. So, and as it says in the diagram there, the real difference is that the read performance is the same for inline and post-processing. It's the write process that's different, and there's more writes to the disk when you're doing post-processing, because it has to write the initial backup to disk in its entirety, and then it has to crunch it down, which involves a number of read-write processes afterwards. Whereas inline, it basically only writes once to the disk, and it calculates the changes as it's doing it. So we believe inline dedupe is far more efficient. Now, in terms of how you actually calculate the backup, there's different ways, because obviously if you're, for example, backing up a physical environment or you're backing up VMware or Hyper-V, both the hypervisors I've just mentioned there support a feature called change block tracking. And what change block tracking does is it calculates what blocks have changed on the virtual nodes that have been snapshotted since the last backup or the last recovery point was taken. So change block tracking, in a simple terms, is calculating the incremental block level changes that's occurred on that virtual environment that you're protecting. And normally with change block tracking, it's quite efficient. It calculates just the unique blocks. But what you tend to find is that in a fairly large environment, change block tracking on its own doesn't really give you a massive amount of data reduction. And there are a lot of virtual backup solutions on the market, for example, that will support change block tracking, but then you're relying on investing in a hardware dedupe appliance or some dedupe technology at the back end to really crunch down the data and retain and minimize the amount of data that you're having to retain on disk. So what we do is when we're measuring dedupe, there's kind of two processes. We've got the initial change block tracking size, which is the incremental blocks. And then we run it through, and in this example, you know, we've done 3 backups. The initial backup was 1 terabyte. The second backup was a slightly larger backup because it was a changes, just over 1 terabyte, and the third one is 1.1 terabyte. So after 3 backups using change block tracking, we may have backed up sort of over 3 terabytes of data because each backup was approximately a terabyte in size, and we've done 3 of them. And these could be incremental backups. You know, we're not talking full backups here. These could be like we've calculated there's been a terabyte of block level change, and then the next backup we've calculated another terabyte, and so on. But what we do is that we deduplicate it real time using inline dedupe, and you'll notice that the initial backup we will drop from a terabyte down to 400 gigabytes, and then these incremental changes, because we've got the base data already deduped on disk and we're using global dedupe, we can basically minimize that down to say 20 gig changes as opposed to over a terabyte of worth of changes. So the overall data reduction after dedupe is down to 440 gigabytes from a backup that should potentially be over 3 terabytes. But then we haven't finished there, because when we're setting up data deduplication, we also enable compression. And what you find with compression is very good, and it complements dedupe really well, because you will get certain data sets that dedupe very well, but they don't compress well, and you'll get other data sets that compress really well, but may not necessarily dedupe that well. And then you'll get data that compresses and dedupes well overall. So by hitting it from 2 angles with compression and data deduplication, we can reduce the data down even further. So in this example, we've kind of given ourselves a 90% data reduction over 3 change block backups. For example, in a virtual environment here, we've dropped it from potentially over 3 terabytes of data protected down to just over 300 gigabytes retained on disk. And this is not make-believe. You know, when you hear from Lisa in a little while, she'll explain real-world ratios of what she's getting in her environment managing Hyper-V and other systems as well. So this is kind of accurate sort of methodology that I'm talking about here. Now, what I'm also going to spend a little bit of time now is talking about UDP itself and how the solution is architected. And what we tend to find when I discuss this with customers is most customers can relate to it quite easily, because most customers have actually quite a similar infrastructure in many ways. So if you take your primary site, and the chances are you're going to have lots of physical and virtual machines, we deploy our recovery point server, our RPS, and the RPS can be delivered in different ways. It can be a software deployed solution where you can factor in your own server and own storage and deploy our software onto it and turn it into a global dedupe appliance. One of the benefits that we can provide with ArcServe is the fact that you know, a lot of data protection solutions on the market today claim that they have good dedupe, but in reality what tends to happen is customers will go out and buy a hardware dedupe appliance because the software dedupe that the data protection solution provides often isn't good enough, and by using something like a hardware device that supports data deduplication, it will basically optimize the storage significantly higher than what the software can do on its own. However, with ArcServe, we believe we're fundamentally different because we are getting data reduction rates which probably exceed most appliance and hardware solutions on the market today. So when we deploy our technology, the dedupe's very, very advanced. We get very high compression. We're using source and target-based dedupe, similar to that process I described before. We can migrate off to tape because we still have lots of customers, especially in the public sector and finance and other areas, that they need to keep long-term archives of the backups for 5, 10, 15, 20 years, sometimes even longer. Sometimes for the lifetime of the information, it has to be retained. But then as you start to roll out the solution, it could be that you've got remote branch offices. And when you've got other sites that you need to manage, it makes sense to, where practically possible, is to dedupe locally every location, because by doing that, you're going to significantly reduce the amount of data that needs to be transmitted over any potential link. And it doesn't matter if you use an appliance or a software deployed recovery point server. Our technology has inbuilt replication, and this is where our dedupe's very advanced, is that we use dedupe built into the replication as well. So before we transmit recovery points between nodes, we're calculating what's unique before we even transmit the logical recovery point off-site. So if I did a backup and it was 50 gigabytes, 50 gig doesn't seem that big, but if you're sending that across a 5 megabit wide area network link, 50 gigabytes of data could take quite a long time to transmit. But if you're comparing the blocks at both ends and you're getting something like a 98, 99% compression before you've actually transmitted, in reality, we're only sending 1 or 2% of that data across the link. And we call that one optimized replication. And as you start to deploy the solution out for disaster recovery, you may have your own DR sites. You may decide to work with a managed service provider or a rack space. We can dedupe at a third level. So if we have a disaster recovery point server running at the DR location, we can, when we're receiving recovery points from various appliances or recovery point servers, we're calculating what's unique coming in from each recovery point server. So if recovery point server at the remote branch office sends in a load of data, and then the head office is also trying to transmit the same data, we will only accept the data from one of the RPS nodes because we're globally comparing all the blocks and only asking for the unique data to be sent through. So once the data gets to the recovery point server in the DR location, we can start to do clever things with the data. We can use virtual standby, which is a technology that allows you to create virtual clones from the backups. And this technology is really good because it allows you to recover very quickly. If you experience a physical or a virtual server failure, you can literally power on a virtual clone within a few minutes and have that presented back onto the network and available for your users to access if something goes wrong. And the virtual standby works virtual to virtual, physical to virtual, and also across hypervisors. So you can actually be backing up VMware and physical servers in production and actually spin up virtual clones into Hyper-V, for example. And there's nobody else in the market that can provide that cross-hypervisor support. And we've run a lot of projects recently where customers are doing that, where they're using Hyper-V for DR because it can help them reduce their licensing costs around their virtualization solution, and take advantage of the fact that we can actually copy and convert VMs from one hypervisor to another. We obviously also integrate with public cloud, so we have a lot of projects underway where customers are looking to use Microsoft Azure, and that also presents a challenge because Microsoft Azure is obviously powered by Microsoft and Hyper-V, so we can take advantage of that and deploy a virtual recovery point server in the cloud. And we can do the same for Amazon as well. And then use that WAN optimized deduplicated replication to replicate recovery points into the cloud. And that's a very interesting conversation as well, because a lot of the cloud-based solutions now charge you for the amount of upload and download that you put onto the cloud and off the cloud. So if you have a solution that's only going to transmit the unique minimal amount of blocks up and down that link, it means it's going to help you save costs and using a public cloud for your disaster recovery. Now, the key thing about all of this is it can be all centrally managed from a single console. And really the data deduplication, I don't want to move away from that topic, because the data dedupe is really the key enabler behind all of this. The whole point of unified data protection with ArcServe is that we want to minimize the amount of data that you transmit between sites. So if you have remote branch offices going to your head office, or your head office being replicated to your DR site, the whole trick about making this scalable and perform really well is to have a very, very strong layer of data deduplication. And really that's why we are starting to go from strength to strength with our customers, and they're starting to recognize how our products work. And I just want to recap on the data dedupe with the source side. We only transmit the unique blocks from source, and we're also only storing the unique blocks from any system that's backed up, because we're using global dedupe. And we're also using dedupe around the replication as well. So you can see here that the solution is very scalable. The dedupe that we have is controlled by software, but we can deliver that dedupe technology as a software deployed solution, and we can also deliver it using our appliance technology, which is a server, the storage, and the software all bundled together. But the dedupe, as I've mentioned already, is very advanced. And what I'm going to do in a second is hand across to Lisa. Lisa works for a company in the UK, and they deployed a solution in the last 18 months or so. And Lisa's going to explain everything, really. She's going to talk about the whole process before it kicked off, the selection criteria, what they did, and how it went from there. So I'm going to hand across to Lisa. Lisa, are you there?
Yes, I am. Hello, everyone. So I would say August last year, I was asked by my company to replace our existing backup technology, which, as Charlie pointed out, was tape-based and very old, very clunky. And it would take, for example, a couple of weeks just to restore a single file from tape, because you had to find the right tape, you had to index it, and I'm sure I'm speaking to people out there who've already been through all of that. Anyway, so I came on board and was given the task of evaluating not just the backup solution, but the DR solution in general. And one of the things that I was really looking for was a way to not only compress what we had, but to simplify the restore function. So I approached our MSP and I said, what options are there? Because obviously, you know, I didn't have experience with it. And they gave me a few that I could try, WebExes to attend, and a few got ruled out because the salespeople were rude, others because they were too complicated or too pricey. And in the end, it came down to 3 products, all of which had dedupe, all of which did good compression, and all of which had a relatively straightforward interface. And then I ran 3 of them on virtual machines, and I backed up some of our standard servers, database servers, and just looked basically at which ones were coming up with the right answers. So ArcServe, as you can see, and this is real-life data out of our recovery point server, is actually giving me a 93% data reduction over a huge volume of data. And what had actually happened, we decided to back up about 10 VMs to start with, and it was going all so well. Everything was backing up regularly, there wasn't a single error. And then all of a sudden, I realized that my hashes database was running out of space. we got greedy. I started to back up every single server we had, and as you might be able to tell, that was over 150 servers. My C drive, which is also the location of the hashes drive, filled up very fast, and it's one of the big gotchas with dedupe. You've got to watch those block sizes, as Charlie mentioned, because if you don't, you end up chewing up the SSD that you're storing your hashes database on. However, we put in a big SSD, which you can just see the second bar up on my graphic on screen, and ever since then, our backup solution has been running really smoothly. We're also running into a virtual machine on Azure, as Charlie has mentioned, and I'm also getting 93% dedupe on that one. So roughly reducing over 100 terabytes of data to about 12 or 13. I'd say that was well worth it. And in fact, management have been so impressed with the results that it's pushed forward the disaster recovery aspect of our product, so that we'll be pushing into getting that fully implemented before June next year, although that's going to take some planning. And one of the things you can clearly see is what Charlie was saying about the ramping up of the data when you first take your backups. Slowly it builds up the full database, and then all it does is the change blocks. So you don't actually end up with huge amounts of data overwriting old data. And I've in fact found it so easy to maintain from the UDP console that we have this on our hardware monitor. So, every couple of minutes we get a reference to our ArcServe server just showing the current results. And as you can see quite clearly, I've got a couple of machines offline at the moment, so they're not backing up, and I will need to talk to those server owners to get them to pick up on it. Anyway, back to you, Charlie.
Okay, Lisa, that's great. And I hope you can see from these examples that Lisa's been given is that this is real-world data. We're not talking about something that's put into a lab and it's not, representative. These are live production servers, and Lisa's backing up over 150 nodes on-premise and then replicating off-site to the Azure cloud, where she has deployed a virtual recovery point server to be able to handle and transact that data into the cloud for disaster recovery. So it's just a good example of, the power of data deduplication. And I think also the way that ArcServe uses data deduplication, it does it in a very advanced, optimized way. And I think the last thing the point I'm going to make about this is that, we do all this using software. So Lisa's just been able to go out and buy decent spec servers and standard direct attached storage, and a small layer of SSD storage. So the overall cost of the solution is very cost effective as well. She's not had to go out and buy SAS disks and dedupe appliances and the stuff that really ramps up the cost of an overall solution. So it just proves the point that if you do have the right dedupe technology in place, you don't have to go out and spend a large, ridiculous amount of money on hardware-based appliances, because that will chew up a lot of your budget, which could be easily used for other IT projects, in your organization as well. So
absolutely.
That's really...
I'm actually... sorry, Charlie, just to add to that, I'm actually hosting a couple of backup virtual machines in standby mode on this server. So obviously the failover aspect of ArcServe has served me well as well.
That's good. And yeah, absolutely. And thanks for that, Lisa. That's really good. I think it's always very interesting for the audience to hear that, it's not just us saying how good our technology is, it's being validated by our customers as well. So what we're going to do now is we're going to open up for questions, just to see, what we've got out there. So are we going to read the questions out now, or?
Yeah, I'll take the one from Abraham Matthew, which is, do I back up to multiple destinations or all servers to one location? I'm just going to go back a couple of slides because you can quite clearly see there's actually 2 locations, but several servers are being backed up in both locations. However, the internal storage, as I've named it, is just 1 server. All right, it's got 15 terabytes of hard drive and a fair bit of RAM, but it is just 1 server. Does that answer your question?
And it's a good point, because that's one of the other key enablers about dedupe. Once you've got that base data committed to disk and written, we're just capturing the incremental block level changes. And then when you combine that with the dedupe, it actually reduces the amount of overhead on the system. And that means that even in very relatively large environments, you can deploy a single server in many occasions to take care of a whole site. Even, we have customers backing up multiple sites if they have the right network and links in place to a single appliance or a recovery point server as well. So that's a good question. Thank you. There is another question here as well, and this is from Alex Howard. I'm going to read it out. If we were to install the RPS on our own hardware, does it install as a VM, as software integrated with a physical Windows Server OS, or is it contained in a physical install? The answer is that if you're providing your own server, we run it on a standard Windows server. It has to be Windows Server 2008 R2 or above, 2012 R2 or 2008 R2. So it has to have a Microsoft Windows license, and it installs on the software. But going back to the other point about can it be a VM? Yes, it can. We do have best practices around that. We tend to recommend if you start to exceed 3-4 terabytes of production data, it's more desirable to have a physical server to give you best performance. But in theory, we do have lots of customers backing up to virtual recovery point servers where they've created a Windows VM and they've allocated the right number of CPU cores and RAM to that VM, and it works quite happily. In fact, when we do proof of concepts with customers to show the technology, it's pretty standard practice for us to do the setup in a virtual environment, so the customer doesn't have to go out and source, expensive hardware to test all the functionality. So it works absolutely fine. A lot of it really depends on how much data you're protecting in the production environment. There's another question here from, I'm assuming it's John Neo, because it says Neo John. And the question is, are recovery point servers needed for the UDP appliance or the remote site? Well, the UDP appliance is a recovery point server essentially, but it has all the management software on there as well. So when you deploy the appliance, that becomes your recovery point server. And when you deploy the appliance, it will start to back up and deduplicate onto itself. In the terms of remote sites, I'm assuming what you mean by the question is, do you need to put an appliance at all the remote sites that you're protecting? And a lot of that really depends on the quantity of data at each site and the speed of the network link to your central site. So we're working on a number of projects recently where customers have got reasonably good links from some of the smaller sites to their head office, and they're only backing up maybe a couple of 100 gigabytes at each site. So there's a strong argument there to say we can do source-side dedupe straight to a central appliance or recovery point server and just capture the incremental changes every day which get deduplicated from source. So that's fully supported configuration. But I would say if you start to go upwards of 1 terabyte of production data, it's probably more desirable to put a recovery point server, which can be virtual, physical, or via an appliance, and then use the inbuilt replication into UDP to replicate between RPS nodes, because you can do things like bandwidth throttling and other things to control the traffic speed as well. Okay, there's another question here from Jeffrey. We are using UDP. Could you tell me where I can check the block size? I think we have chosen 32K blocks for disk to tape migration. Well, the block size is actually set when you're creating a data store on the recovery point server. So when you go into the console and you select recovery point servers, you will see your data store, hopefully with a green tick next to it. And if you modify it in there, that's where the block size is set. If you are doing disk to tape, we do kind of recommend having a larger block size. You will still get very good dedupe ratios overall having a 32K block size. We're talking that the margins between 4, 8, 16 and 32K, we're talking maybe a few % more storage use, but it does make a big difference when you're migrating to tape. With having a larger block size, it gives you the most optimum disk to tape performance.
Yeah.
So I hope that answers your question. Another question here from William Gaillard. Yeah, sorry for that. For the client mentioned, roughly 100 servers to back up, what are the I/O requirements for the recovery point server, and what's the recommended configuration of disk, RAID, block size, etc.? Is it best to have the hash index on separate SSD disks? What spec a server? Okay, well that's quite a comprehensive question. We could probably spend about half an hour debating that. But in summary, we tend to recommend, for most customers, it depends on how many disks that you have for your backup destination. If it's a disk system, it's in multiples of 3 disks, RAID 5 is recommended. If it's multiples of 4 disks, RAID 6 is recommended. We tend to recommend to put the hash destination or the hash folder, which is the dedupe hashes, onto an SSD disk to give you optimum performance. You can run it in RAM mode as well. The index volume can be running on the same volume as your data volume, but if you've got a very, very large environment, we do recommend putting the index on a separate RAID 10 volume to give you the most optimum performance. But again, that's only if you've got huge quantities of data, what I would say upwards of maybe 100 to 150 terabytes of production data. That's the sort of environments where you really need to configure the disks very articulately to make sure they're configured to be fully optimized. But in sort of small to medium-sized environments, it doesn't make that much difference. You can put the index on the data volume, on a local drive, on the OS, whatever. Okay.
Can I answer William's follow-up question that he's got there?
Yes.
Which
Absolutely.
is, how is your IPS configured in terms of disks? It's directed to me. So I've got 15 terabytes of disk, all in a RAID 6 array. I dislike the fact it's only RAID 6, but it should be sufficient to keep things safe. But I am not just backing up to the RPS. I'm replicating into Azure as well. And physically on the same server, I'm also running 2 machines in virtual standby. I'm not quite sure what you mean by, have you had any issues with the purge not running efficiently? I've not had any issues with the UDP server retaining data that it shouldn't do. I'm thinking that's what you mean, but maybe you could drop me a clarification. Anyway,
Okay,
back to you, Charlie.
thanks, Lisa. Okay, another question here actually. This is from David Murphy at Assistech. Is it possible to dedupe across multiple IP range networks? We have different network IP ranges and DR sites in various offices. Yes, in theory, it makes no difference to us. As long as the recovery point server can see either the virtual proxy, which is initiating the agentless backup for your virtual machines, or if it's a physical client on these different IP subnet ranges, as long as we can communicate both at an IP level and via security. So a lot of it depends on how you've got your routers configured, but if they're all communicating, we can back up across different subnets. You can have recovery point servers on different subnets communicating with each other. Works absolutely fine. And we also have ways to set up, sorry, carry on.
Sorry, I was just going to add to that, which is if you install a second recovery point server, you have to be able to see the admin dollar share between the 2 RPSs, otherwise they can't communicate directly. That's the only problem that I found when setting up my Azure connection.
Yeah, and that's if you're using a standard replicate to 2 RPSs managed in the same logical domain. But we also support replicating to what we call a remotely managed RPS, where we can just do it through a public IP address at the remote location. And we understand NAT configurations as well, so we're NAT aware. So even if your recovery point server is sitting behind a firewall with an internal IP address, we will be able to communicate as long as we open up the right ports, which is just 8014 and 8015 for backup and replication. So yeah, we can have a more detailed discussion about that on another call if needed. Okay. There's a question here from Russell Snelson. Please convince me why I should rip out Veeam from our data center and replace with ArcServe. Well, the idea of this call is not to be a competitive. I'm not here to bash our competitors. All I will say is that, you know, one of the big advantages that ArcServe has over Veeam is the fact that it supports physical as well as virtual. And a lot of customers have to deploy 2 backup solutions, where obviously Veeam is a good solution, but it can only protect their virtual infrastructure. The other point is Veeam is that even though Veeam talks about having inbuilt data deduplication, a lot of customers using Veeam end up buying hardware-based data deduplication devices. And the main reason for that is that they don't feel that they're getting the right kind of compression levels by using Veeam software dedupe on its own. And we've not yet experienced ArcServe customers coming to us saying, oh, we're not happy with the data reduction that we're getting from ArcServe. And you've just heard from Lisa there, you know, we're getting data reduction levels on a common theme across exceeding 90%. And so to do that with software only dedupe is very, very good. The other thing is we use source-based dedupe. Veeam only uses inline target-based dedupe as well. So they will send the full size of the incremental backups across the SAN or the LAN to their backup server, and it will dedupe at the target, but it won't dedupe from source. So there's a number of reasons there, but at the end of the day, it's really down to you as a customer to decide what you want to do there. Okay. Is there any questions? I think we've taken quite a few questions there. Do we have time for any more, or we?
Yeah, you can do a couple more.
Okay, cool.
Just reading William Gaird's comment about his French surname. Sorry about that.
All right, apologize. Okay, I don't know. Okay, I'm just going to go up to the top of the list here because there's a few new ones coming in. So there's here Satish Kohan. When backing up using RDP, are snapshots always required, or can they be created away from where the VMs are? When we're doing VM level backup, we basically, you know, use the hypervisor to create the snapshot. So the actual process of taking the snapshot of the VMs is managed by either VMware or Hyper-V. You can configure both VMware and Hyper-V to set up a specific volume, because it's quite a common scenario where customers will say, you know, their data stores are 90% plus utilized, they don't have free capacity to hold snapshots, and that causes a problem. So you can configure you could add a new volume into your data, you know, and create a separate data store, and then configure the config files for the VMs to snapshot not in the default location, which is the same directory where the VMDKs or the VHDX files exist, but they can actually snapshot onto a different volume if you want. So we can work around that. But once we basically deduplicate and copy the unique data from the snapshots to the recovery point server, we delete the temporary snapshots straight after the backup completes. So we don't retain or hold any snapshots once the backup has completed. So I hope that answers your question there. Hold on. Another question here from Mintu Matthew. Will there be any firewall and NAT issues? I had some serious issues with one solution which had NAT problems. We don't support NAT configurations at an agent level, but we do fully support NAT configuration between recovery point servers. So if you have an on-premise site that's using a recovery point server and it's deduplicating all the backups, and you're replicating, for example, to a cloud server that's behind a NAT firewall, we can configure in the console that you can tick an option to say you're using a NAT configuration. and we can then route the traffic through the firewall to the internal IP address. So we do fully support NAT configuration between recovery point servers when we're replicating the backup data. Okay, there's a question here from Tejamon Jose, or Jose Tejamon. I don't know if it's first or last name there. Is it agent-based after deliver to RPS? How about Exchange server granular backup? That's a good question. We can deploy agents onto VMs if you want. From a commercial perspective, it makes no difference to us if you do agentless backup of VMs or you deploy agents onto the VMs, because there are sometimes scenarios if you're running things like raw device map volumes or iSCSI volumes on a VM, that it makes sense to deploy an agent, because the agentless backup wouldn't be able to protect non-VMDK or VHDX volumes. So we can work around that with agents. Certain applications and databases do require an agent, things like Active Directory to do granular object level recovery. We need to put an agent onto your domain controller, even if it's a virtual node. Exchange, currently we need an agent on the Exchange, not so much to do an Exchange backup. We can do that agentless, but we've actually just launched a brand new Exchange granular restore tool, and as part of the process of doing a granular email or a mailbox granular restore is that we need to mount the Exchange backup volume before we can load this tool up to index the EDB file and do a granular restore. And to do that at the moment, you do need to use an agent to be able to mount the recovery point onto the backup server. But we are bringing out a new version of UDP early next year, and we will be able to do granular email item recovery from an agentless backup using our new Exchange granular restore tool. So that's something that's going to be changing in the next month. Okay,
and I will say I've seen a pre-release version of that, and it looks very good and very easy.
That's good. Okay. Okay, so there's a question here from Duncan Lawson. Can you guarantee that any 1 terabyte of data after dedupe will be 40 gigabytes no matter of the data type, structure, source of the data? Well, no, we can't guarantee, because you sometimes get data that doesn't compress very well. It could be highly compressed or in a format that it just doesn't dedupe very well. What I would say is that on average, if you took a realistic representation of a production environment where you're going to have file print servers, you're going to have SQL databases, you're going to have Exchange, you're going to have other applications, on average across the whole environment, I would stand by the fact that you would probably get data compression rates anything from 85 to 95, if not somewhere in between that range. You will get the odd scenario where you may get certain sites of data that doesn't dedupe very well. But that's one of the reasons why we compress as well as dedupe. So we're kind of hitting the data from both angles to optimize it as much as we can. So we can't guarantee it, no, but what I would like to say to you is that we would be happy to let you evaluate the software, and you could test it and see what ratios you get, after it's running for, say, 30 days, and you can get a sort of fair feel for what the data reduction would be in your environment. Okay, I think we're going to wrap up now. I think we've asked quite a lot of questions. It's just coming up for 3 p.m. now. Okay, so thank you very much, Lisa. I really appreciate you coming on the call today. And that's good.
It's been a
and
pleasure.
We've had some really good questions. Oh, that's great. Thank you. And I'm going to pass it back now to the hosts of the call to wrap up. So thank you very much.
All right, fantastic, guys. That was a wonderful presentation. Thank you so much. So, guys, we do still have some questions that have gone unanswered, but somebody with ArcServe will be able to follow up with you. And if you had to step out or miss any part of today's presentation, you'll be getting an email in a few days with a link to view the webinar on demand, as well as a link to download a PDF copy of these slides. So special thanks to ArcServe for creating today's content and sponsoring this great event. And thanks to each and every one of you for tuning in today. We hope to see you back soon for another Spiceworks Partner webinar. But until then, stay safe and keep it spicy.